Alright guys and gals, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video. And so for the past 2 days, we've been working with vertex form of quadratic functions, right? Where you can just tell what the vertex is immediately from looking at the equation. And you were also able to find many different attributes from that equation. So today, we're going to learn standard form of a quadratic function, okay? This is the other version of the quadratic function, okay? So today we're going to be able to identify the difference between vertex and standard form, whether the graph opens up or down, has a minimum or maximum, the y-intercept, and we're going to be able to find the vertex from standard form. So take a look at this real quick, guys. Standard form is of the form f of x equals ax squared plus bx plus c. This shouldn't be anything new, really, because you've definitely worked with this form when you were doing factoring. Remember, ax squared plus bx plus c, right? You got a, b, and c. Yeah. All right? So based on how the equation's written, though, we should be able to tell if the equation is in standard form or in vertex form. All right, so look at example 1. All we're going to do for example 1 is we're going to identify whether the equation is in vertex form, standard form, or there's very special situations where it fits both forms. So take a look at number 1 right here. F of x equals x squared plus 3x minus 2. Do you think that's in standard form or vertex form? Standard, that's right. It is in standard form. And what gave that away to you? How did you know that? There's no parentheses, right? That's a big giveaway when there's no parentheses, right? Now I'm going to tell you right away though, the number 1 clue, like for sure, to tell that it's standard form is if you see x squared and the x in the same equation. You see how it's x squared and there's an x over here? Yeah. That doesn't happen in vertex form, right? Okay, but let's look at number 2. F of x equals parentheses x minus 3 parentheses squared plus 2. Is that vertex form or standard form? Vertex form. And how did you know that? It has parentheses, that's right. Alright, there it is. So why don't you guys go from 3 to 6, try those on your own, tell what form it is in, and remember, I'm going to give you a hint, there's one that is both. So let's check 3 through 6. What did you get for number 3?
Vertex.
Vertex form. How did you know? Parentheses. Number 4, what did you put for number 4?
Standard.
Standard y.
2x.
Right, because you see the x squared and the x, right. And also you see there's no parentheses, but for sure though, the best way to tell is if it's x squared and the x in there. What about number 5? Vertex, y. Got the parentheses. And what about number 6? Number 6 is both. Why did you say both though? You can find the vertex. What's the vertex on number 6? Right, the vertex you can see is 0, negative 2, right? There's no h, so it's 0, and then negative 2 is the k. But then also it's in standard form because why? What? There's no parentheses, right? If there's x squared and x. That one doesn't show the x, but... Yeah. All right, let's go down here now. Let's take a look at the attributes. So, just like you can tell certain attributes of a parabola from vertex form, you can also identify certain attributes of the parabola from standard form. So, okay, watch this real quick. Remember, the vertex form is f of x equals a times x minus h squared plus k. Now, in the vertex form, guys, which of those variables told you if the parabola opens up or down? The a, right? And that's the same for standard form. The a in standard form and vertex form, it's actually the same a. So a is going to tell us whether the graph opens up or down. All right. If a is positive, then the graph opens up. That's right. And remember, if a graph opens up, that means it has a minimum or maximum? So if it opens up, it looks like this, right? Is there going to be a minimum or a maximum on a graph? A minimum, right? Because down here, that would be a minimum. Okay, if a is negative, wow, that was ugly. If a is negative, then the graph opens down. If it opens down, that means there's going to be a, right, because it's going to look like this, and up here would be a maximum. Now finally, which of the variables in the standard form, a, b, or c, do you think tells you the y-intercept? It's got to be b or c because we already used a. C. It's going to be C.
Where'd you get A, B, and C at? I know.
Up here, standard form, ax squared plus bx plus c.
Oh.
Yeah, this notes is all about standard form. So it's C. So C tells you the y-intercept. So the y-intercept in standard form is always going to be parentheses 0 comma what? What's the y value going to be? C, that's right. It's going to be 0 comma C. So whatever your C is, that's going to be the y value for the y-intercept. So let's take a look at some examples real quick. Example number 2 right here. We're going to tell whether the parabola opens up or down, whether it has a max or a min, and also give the y-intercept. But first, let's make sure we know how to find A, B, and C from the standard equation, okay, standard form. Because we need to make sure that we don't mess that up. That's the basis for everything. What is the A value on number 1? What is it?
3x squared.
So it's not 3x squared. A, B, and C are just numbers.
What do you mean?
3, it's 3. It's just 3.
Oh, so it doesn't matter what the x is.
It doesn't matter about that. The A is the value in front of the x. So what is B then? 5. And what is C? -7. That's right. So make sure you keep the signs with the numbers. -7. Okay, so then, does this graph open up or down?
Up.
Up, and how did you know it opens up?
Because it's positive.
What's positive?
The
A, because A is positive, that's right. Does it have a max or a min? A minimum, because it opens up, so it looks like this. And what is the y-intercept?
-7.
0,
-7.
-7.
So that's what you want to start with.
Right, because y-intercept is a point, right? It's 0, -7. It's got to be a point. All right, so you guys try 2 and 3 on your own. All right, let's check number 2 and 3. What'd you get for the A value on number 2? -1. What about the B value? 3. And what about the C value? 0. It's not there, but remember, it has to be a number, so you can't write none. None's not a number, so you're going to write 0. All right, does number 2 open up or down?
No down.
Down. Why does it open down?
Because it's negative.
What's negative?
The
The A, right. You got to specify. It matters which one, okay? Does it have a max or a min? A max, because it looks like this, and there's a maximum on that. And what about the y-intercept? What's the y-intercept? 0, 0, right. That 0 comes from the C. Okay, then on number 3, what is the A value?
-3 half.
-3 halves. What about the B value?
3.
3, and what's the C value?
-2.
That's right. Does it open up or down?
Down. Up. Wait.
Because there's a negative.
Down, because what's negative,
A
Nathan?
is.
Yeah.
A, that's right. Good.
Max.
Max
0, -2.
and 0, -2. Very good. All right, let's turn it over to the backside then. To the backside. Now, this is the only really new thing right here, is finding the vertex in standard form. Because, remember, when we're in vertex form, it's really easy, right? You can just look at the equation, look at H, look at K, boom, there it is. But standard form, you actually have to go through a process to find it. It's not as clear. See, standard form is good because it shows you the y-intercept immediately, but it doesn't show you the vertex. All right, so what you're going to do is, we can, remember, a vertex is always in the form of x, y, right? Because it's a point. So it's x, comma, y, right? That's a vertex. So when we're finding it in standard form, we're going to find the x value first. And after we find the x value, then we're going to find the y value, okay? We can find the x value by using this formula, -b over 2a. So let's try with this example right here. F of x equals x squared minus 6x plus 5. So remember, the formula is -b over 2a. So what are the two variables I need to identify? A and b, right. So what is a in that equation that we're doing? 1. Right here, you see x squared? Yeah. That's the equation we're working with, right? We're trying to find the vertex for that equation. So the a is 1. What's b? -6. Okay? Now, my formula is -b over 2a, right? So I'm going to write it like this. Look, negative, and then what's b?
6.
What is b?
6.
-6. Yeah, be careful for the signs. So it's -6 over 2 times what?
A.
Which is? 2 times 1. Good. And so if we simplify this, what is -6?
6.
Right, it's +6. Because this is like saying -1 times -6, right? That's +6. And 2 times 1 is?
2.
So now we have 6 over 2, which simplifies to what? 3, because 6 divided by 2 is 3. So my x value, I just found it. The x value is 3. Okay? So now we need to find the y value of our vertex. So we're going to take that 3 that we just found and substitute it into every x we see in our equation. Okay? So after I substitute my x's, what's my equation going to be? 3 squared. There's no x. X is gone because we replaced it with a 3. So 3 squared, and then? Right, minus 6 times 3 plus 5. That's right. So that's the next step. We replace all the x's with the 3 that we just found. Okay? And then in step 3, we're going to solve that equation. So we have now 3 squared minus 6 times 3 plus 5. What is 3 squared? 9. Then what is negative 6 times 3?
3.
Negative 6 times 3.
Negative 18.
Negative 18. So minus 18. And then plus 5. And then we solve that. What is 9 minus 18 plus 5? Negative 4. Yes, it is negative 4. So we found the x and we found the y. So what is our vertex then?
3, negative 4.
Our vertex is 3, negative 4. That's right. Boom. There it is. You see, you find the x value first, plug that in, and then you find the y. 3, negative 4. So let's try an example then. Look at example 3 right here, number 1. So we're going to find the vertex of the quadratic function, then we're going to give the axis of symmetry. So what are the variables that I want to identify? All right, but let's just get in the habit of doing A, B, and C because we are going to be using all 3 eventually. So what's A? 2. What's B?
4.
And what is C?
7.
That's right, okay. And so what is my formula for finding the x value of axis of symmetry?
Negative B over 2.
Negative B over 2a. It's very important. And so now we're going to just replace the variables with the numbers that we have that equal those variables. So it's going to be negative what? Negative 4 over
4.
2 times, right. And so yeah, if we simplify this, it's going to be negative 4 over 2 times 2 is?
4.
4. And then negative 4 divided by 4 is what?
1. Negative 1.
Negative 1, that's right. So the x value is negative 1, right? And what do we do with that negative 1? Plug it into all the x's. So now our equation is going to look like what? 2.
Times negative 1 squared.
So make sure it's in parentheses though, because we don't want to mess up the order that we do things. 2 parentheses negative 1 squared, then
4.
plus 4
Times
times negative 1
7.
plus 7, right. Now, so this is the part you want to be careful. Don't mess up this first term right here. The 2 times negative 1 squared. What do I need to do first here?
Square the 1.
So you're right. We're going to square the parentheses, right? So we're going to square the negative 1. If I square negative 1, what does that become?
1.
So now it's 2 times 1. And then what is 4 times negative 1?
Negative 4.
So minus 4. And then plus 7, right? And now we simplify one final time. What's 2 times 1?
2.
So we got 2 minus 4 plus 7. What is that?
5.
It is 5. That's right. So what's our vertex then?
Negative 1, 5.
Negative 1 comma 5. That's right. All right. And so if we find the vertex, like right there, what's my axis of symmetry? X equals negative 1. That's right. So guys, try the second one on your own. Go. All right, so let's check this last one, make sure we all get the same thing. So number 2 right here, we're going to find A, B, and C. What is A on number 2? 3. What is B on number 2? Positive 12. And what is C? Negative 7. So what is the formula again to find the x value? Negative b over 2a. That finds the x value of the vertex. So we're going to have negative what?
12.
Negative 12 over 2 times 3. That's right. That's going to simplify to negative 12 over what? 6, and negative 12 divided by 6 is? Negative 2. So the x value is negative 2. So then we take that negative 2, we plug it in for all the x's. So what's my new equation? 3 times negative 2 squared, that's right, plus 12 times negative 2, right. Be careful, don't switch it up now. It's negative 2 all the way through. Minus 7. Okay, what's the first step here on the first term? 3 times negative 2 squared. Square, right, we square that negative 2. When we square negative 2, what does it become? 4. So 3 times 4, right? And what's 12 times negative 2? So we got negative 24 minus 7, right? So 3 times 4 is what? So we got 12 minus 24 minus 7. Which is what? That's negative 19. Very good. And so what's your vertex? Negative 2? Negative 19. Oh, geez. What's my comment? All right, closes 9. Whoa. And if that's my vertex, what's my axis of symmetry? X equals negative 2, right? It's just the x value from the vertex. And that is it, guys. So that's going to end these notes. So until next time, see you then. Peace.